Hi, it's Miss Chapman, and this is Basic Set Theory, our first topic in probability. This actually isn't in Cognity, but it is in the Oxford book and other locations, which it assumes you know. So Cognity, the next section in Cognity assumes that you know basic set theory, but I'm going to teach it to you. So you should be taking notes in your math journal. Um, that can be digital, it can be printed, but I would write basic set theory. And we're going to go through that. And then in class the next day, tomorrow, or maybe the same day, if you're in AI, we will be doing a problem set on that. So in elementary sets theory, a set is just a collection of objects or elements, and it is usually denoted by a capital letter. For example, let me get my pen working here. R is usually denoted as the set of real numbers. And remember, real numbers are like 1, 2, 3, 4, 5, 6, but also pi is a real number. They can go on forever. They just can't be imaginary. So nothing with the square root of -1. And Q is the set of rational numbers. So rational numbers are numbers that can be written by a fraction, like 2/3, 1/4, that kind of thing. And like 1/3, they can be going on forever. Um, of rational numbers. And they can be written as a fraction. So that's why it's Q because of quotient. Like it can be a ratio or quotient of two numbers, rational numbers. All right, so when listed, the elements of a set are separated by commas and included between these two brackets, which I'm terrible at drawing. I call them squiggly open bracket and squiggly close bracket. I'll do my best, but I might mess up. So, for example, natural numbers, which are all positive integers and zero, um, would be 0, 1, 2, 3 comma, etc. And then squiggly thing that you really think I'd be better at drawing these brackets considering I've taught for so long, but I'm not. And then Z is the set of all integers, and that's always used for integers. So integers are positive and negative whole numbers. Zero is randomly an integer, and so on, dot, dot, dot. And that dot, dot, dot includes, you can keep going with that pattern. But it doesn't have to just be these classic sets that you learned. I can also make up a set like A is the set 1, 5, and 8. B could be letters like X, Y, and Z. That could be a set. And we can also just have a set of like anything. Amanda, Ben, and Einstein can be a set. So it's me, my husband, and my dog in a set, elements of three elements. So now you kind of have an idea of what a set is, and seems easy, right? Well, it can get more complicated. So we have to know the notation because in probability, they use these notations all the time. So we need to know how they write them. To declare that an element is contained in a set, we're going to write, for example, let's say that A is in set B. We're going to write this guy, kind of like a little euro symbol, but it's more curved. A is in set B. And if it's not in the set, like let's say F is not in set B, you do the same symbol and just like cross it out and write B. So F is not in set B would be written like that. Some other symbols to know are an empty set. So an empty set can be written as this no solution sign. You might have used this when you solve the quadratic formula and there's no solutions or sets of equations, that kind of thing. And then you can also just draw a set and put nothing in it. These mean the same thing. I don't want to put an equal sign because you should never put equals no solution. But yeah, those mean there's nothing in that set. Okay, so let us consider the set A equals 1, 2, 3, and the subsets of A are all of the or none of the elements of A. So there are actually 8 subsets of A that we could write out. So we could, of course, have the subset just 1 a subset just two, and a subset. How bad are these brackets? Just three. And then you can also have sets of two. So we could have a set of one and two, two and three. The brackets are really bad. And one and three. Gosh. And especially with this pen, it's supposed to be this bracket symbol. I promise I'm drawing this little bracket symbol. So there's six sets, but I did tell you that there were eight subsets. So the other subset would be the set of all three of them. And the set 1, 2, 3, 2, 3, 1, 3, 2, 1, those are all the same sets. We generally write the numbers in order from lowest to greatest. And if it's a set of variables, we write them in alphabetical order. But technically, those are the same sets. The order doesn't matter here. And then, of course, the null set of none of them. So these are the subsets of there. And if you look, there are three things and eight subsets. So there's actually a rule to know how many subsets because with three elements, I could write them all out. But if it was a set of, 27 numbers, I don't want to figure out all of the things. So there is a general rule for the number of subsets. Let me move my script notes. If set A So if set A contains n elements, in this case it was three elements, but we're going to say the letter n elements, there are 2 to the n subsets. So just to recap, we had three elements, 1, 2, and 3 in our set, and so there were 2 to the 3. And 2 times 2 is 4, times 2 is 8. So there were 8 subsets with three elements. And this works if there were 40 elements in your set, you could do 20 to the 40 to find the number of subsets, which when we get to probability, you're going to need to know that rule, which it just assumes that you do know. So I taught you that. Okay, so if A equals 1, 2, 3, so we have a set A that has 1, 2, and 3, and we have a set B with 1 and 2, we can say that B is a subset of A. How would we write that? Well, we could write it normally, but it's math, so we have to have something complicated. Just kidding, it's not that bad. So we can say that B is a subset, which is like this U shape with a line under it of A. So B is a subset of A. And then don't forget, actually, I think I made a slide for this next thing. Don't forget that for our subset, the null set is always a subset of a set, which is kind of easy to forget, and that every element is also a subset of itself. So we saw that before with 1, 2, and 3. Null set was a subset, and then 1, 2, and 3 was also considered a subset of itself. Confusing, but not crazy hard. Okay, so next is Venn diagrams, one of my favorite things, and I'm super excited for Venn diagram problems in class. So when we talk about like a universal set or a big set, they often use the letter S for sets. Get it? S sets. And this one has the elements A, B, C, D, E, F, G, H, I, J. So we also have a subset A, and that subset has A, B, C, D, and E only. So we're going to look at a couple different things of this, but first let's put it in this Venn diagram. Nope, I have to draw the Venn diagram. So I'm going to draw a Venn diagram of this, and for the Venn diagram, you're going to draw a rectangle. Wow, that's pretty rough. I got to get better. The pen is getting better, but it's not great. And I'm going to call this set S. And in set S, there is some subset I'm going to call A. Maybe I should change colors here. Okay, so in A, we had A, B, C, D, and E, and then F, H, G, I, and J are outside of it. So A is a subset. So everything is in the set S, and you can see that A is just a subset. So this is an easy way to organize this data. We'll be doing this just for a little bit. We have to add math to this, so yeah. Okay, and we can also look at another subset. So now we have subset B. We had subset A and we had subset B. Can I bring back that beautiful image? Yes, I can. So let's say we now have a subset B. in addition to this. So A still contains A, B, C, D, and E. And B looks like it has some repeat elements here. Um, I hope I'm writing it right. Do you see that D and E are in subset B? But just to recap, A had elements A, B, C, D, and E. And I probably shouldn't be switching between capital and lowercase. It's just easier to write lowercase, I mean uppercase. So there is some overlap in the subset, but let's draw a complete Venn diagram. And I should have drawn this bigger, so I'm just going to draw it bigger on my paper. Okay, so we're still calling this whole set S, and we have two subsets. So I'm going to draw subset A over here, and A contains A, B, C, D, and E, but subset B is going to contain D and E, F, and G. And then H, I, that's more of a J, isn't it? And I are all hanging out here. They're all in set S, but not in those two subsets. So you can see here that there's an overlap where D and E are actually part of subset A and B, and we're going to learn how to write that. And you might be like, wow, this diagram is really great and all, Miss Chapman, but how is it useful? So normally we don't actually put the elements, especially if I'm looking at like a football roster for everybody that plays soccer in all of Germany. I'm not going to sit out here and write every player's name. So instead, we tend to put the number of elements. So instead of putting A, B, and C, I'm just going to say there's three things here. And in the middle, instead of putting D and E, I'm going to say there's two elements here. The same for this one and three here. And let me erase it. So this is what we're going to be using it for because then we can calculate probabilities from this and analyze it better. So I can still see that there are a total of 10 elements in set S. I don't have the arrow on. There are 10 elements, so 3 plus 2 plus 2 plus 3 is 10 total. 5 of them are in A, 4 of them are in B, 2 of them are in both A and B, and 3 of them are not in A, nor are they in B. Um, so yeah, we can write that mathematically. So the number, it's not really an in, is it? The number of things in A would be equal to 5. Be careful not to say 3. That's a common mistake because these two are in A. They're just also somewhere else. The number in B is 4. The number in all of S here appears to be 10. So those are some things that we can figure out. Be careful that A plus B does not equal yeah, be careful because sometimes we can double count that too. Okay, let me flip this over. So now we're going to look at how to write some of those things. Let me clear this. Okay, so we usually, did I skip a page? We usually deal with large universal sets in a Venn diagram and not arranged. Yeah, I already did this. Sorry, moving on. Yep, I explained that. Okay, let's look at some basic operators. This is where I thought we were going next. And yeah, it's the best I can do. So now we're going to study some basic operations between sets. So we again have this giant set S, we have subset A and subset B, and there are some overlapping members in each of these. So D and E are hanging out in both of these subsets, and that is totally allowed because maybe it's like all the people in our school and subset A is people that like soccer, and subset B is people that like sewing, and some people like soccer and sewing. It can happen, it overlaps. So some things that we want to look at are complements. Yeah, thought I put it in this PowerPoint. I made this PowerPoint like Friday and I'm just not filming the video. So the complement of A, so A prime is considered everything that's not in A. So for our subset, everything not in A would be J. Well, I guess I can write it out here. And maybe not in red. A prime for us is everything that's like not an A, so anything that's not in that middle circle. So for us, it's open bracket F, G, H, I, and J are A prime. So it's everything that's not an A, also known as the complement of A. Okay, the next thing that we need to know is the union. So union is that overlapping part. It contains all of in the parts. So it contains all of the elements that are either in A or B. So for us, what did I say? People that like football and people that like sewing. So it's all of those people. So A union B, also known as A or B, people that like football or people that like sewing all together. For our set, it's going to be the set A, B, C, D, E, F, and G. So all of those, but not H, I, and J. Those are not in there. But what if we just want the people that like both? So that's not union, and that one's easy to get. I feel like the U makes it easy to be union, but that means all of the things. So the union is upside down. And kids get this confused with prime. So this is the intersection, like where they overlap, just this part. And so for us, a union B is the things that are in both sets. So for us, it's D and E, yeah. D and E overlap. So these people that like the football and like the sewing, they like everything. And we're almost done. So last is mutually exclusive, and I feel like we know this from everyday language. If something's mutually exclusive, if people only like one thing or only like the other. I really can't think of an example right now in my mind, because I was about to use chocolate and vanilla, but I like chocolate and vanilla. But maybe you're at a school where everyone just likes chocolate or they like vanilla, but they don't like either one. There's no overlap. Then we would say that those are mutually exclusive, mutually exclusive. So A, section B would be a null set, is a null set. There's nothing in that set. I don't like the answer key has an equals or the notes that I wrote down, but um, I feel like equals null set doesn't really make sense mathematically, but this is a null set. So A union B is a null set. Yeah. So in this case, A B, like the set A union B, is actually equal to the number of things in A plus the number of things in B. But that's not always the case if they overlap. So you have to be careful when we have that diagram that we had before here. I can't remember what the numbers were. Let's say it's like this. A lot of students like to say that they would add up 7 things are in A and 7 things are in B. So A and B is a total of 14 things. But if you look here, there's actually only 12 things being measured here, which will matter when we do probability. And I think that's it for this video. I feel like this topic was pretty self-explaining, but we're going to practice using these symbols and Venn diagrams in some problems that are, of course, really difficult in class tomorrow. Thanks so much.